Hey everyone, Dr. Tracy here to go through what you should be working on this week in CISGAME 403. I hope you've had a chance to read the announcement, but it does tell you that we are continuing with Python games. We're working this week on Chapter 11. So, taking a look at Chapter 11 in the Python games page, you'll see that the new things that are added to this is string formatters, conversion specifiers, and using the random module discussion. So our discussion that will come out of this chapter is how would you rewrite the Bagel deduction program? The original program creates a list of numbers 0 to 9, puts them in random shuffle. So you're going to be focusing on random here, on how you could rewrite it. But let's look at Chapter 11. The Bagels deduction game plays a game where a player tries to guess a random 3-digit number that the computer generates, and then after each guess, the computer will give it some feedback so that you can see how close you are to being right. If the answer is bagels, then that means none of the 3 digits are correct. If the answer is pico, then it means one of the digits is the right number, but it's in the wrong place. And Fermi says that a digit is correct and in the correct place. So your result would look a lot like this result in the sample run of bagels. So guess number 1 is 1, 2, 3. The response Fermi means one of those numbers is correct and in the wrong place, or in the right place. 4, 5, 3. See, they're assuming 3 was it. But the response came back pico, which means one digit is correct but in the wrong position. That tells you that 3 is definitely not one of the numbers because it's either 1 or 2 that produced Fermi here. So next guess, 4, 2, and 5. That comes out with Fermi. And since 4 and 5 are used in both of these, then it's going to show that Fermi is the number 2 that was correct. So 3, 2, and 6. 3, 2, and 6 is going to give bagels. None of the digits are correct. 3, 2, and 6 is not the correct numbers. Try something else. 4, 8, 9 gives bagels. 0, 7, 5 gives Fermi. 2 numbers are in the correct place. Okay, looking back, have we used it in the other ones? We put a 5 here and it came out Fermi. We put a 5 here and it came out pico in the wrong place. So 5 is going to be that in that place. Now, so we'll leave 5 there. Now it's either 0 or 7 that are correct. So try and do it with 0 and a different number. And it comes out wrong. It's in the wrong place. So try to put the 7 there with the 1 and you get it. Okay, so that's the way the game is played. You're guessing this random number based on feedback. So in the code that's given here, which I'm going to go over, there are some functions that we set up. First of all, we need to get a secret number. And the computer is going to pick that by using random.shuffle. And numbers is a list of numbers from range of 10. So it's going to pick it's 3 numbers once it shuffles them, and so that we don't know what they are. Then it has get clues. If the guess is equal to the secret number, you got it. Otherwise, if the guess is equal to a secret number I as it goes through each one of the numbers, if it's exactly equal, then we put Fermi. Otherwise, if it's in that but not equal, you put pico. And if at the end of that there's nothing, then you put bagels. So that's what happens there. And this is only digits, is to make sure that they don't put in letters. So here's the game itself. I am thinking of and this is where the string formatting is coming from. And so I did on Python games give you a link to string formatting right here. String formatting is based on C style formatting, but let's open up this page. C-style string formatting is used to create format strings. The percent operator is used to format a set of variables enclosed in a tuple together with the format string. Okay, what that means is when you write something like this, print hello, comma, print, the percent S exclamation point, you're creating a string. And then at the end, you say, fill in those percents with the variables that I give you. So it goes back and replaces this percent as a string for the name. And there are different types of format, like this is for a digit, percent %D. And so you can see the examples of those, and that you can use more than one and how it works out by clicking on this link. But anyway, back to Chapter 11, Bagels game. It's using this string for the number of digits that was entered, which is a variable displaying it as a string. So there's just some print statements that give the instructions on the game. Then it says the secret number. I've thought up a number. Guess is 1. While you have more guesses to take, then it's going to check to make sure it's only digits and input the number of guesses and save the guess that is taken. Then it will print clues as listed before. If it equals the secret number, the game is over. If it is greater than the max guesses, you run out of guesses. Do you want to play again? So Bagels itself has a flow chart. And as you're starting to build your own game, thinking about flow chart, this is the way that I would looking at having flow charts run to show the logic of the game. And you can see that the flow chart transfers exactly to the way that it's set up within Python. All right, I hope that's helpful, and I hope you figure out a new way to select random numbers, and you can refer to the posted resources on the random module using the random module and also Python random. And using the random module discussion, you're going to post a link to your modified game, but also just tell me why you chose to do it differently. All right, that is it for the week. And if you have any questions, please let me know. Otherwise, have a good week.